Hello guys,
I'm Joshua.
I am Likit.
I'm Chetan.
I'm Harshit.
We are from CS Department of Sahyadri College of Engineering and Management. We are doing a simple presentation on 8086 microprocessor using DosBox.
Hi everyone. I'm Harshit, and now we'll be seeing how to install DosBox on your computer. And these are the steps to install DosBox on your computer. The link will be given in the description below. What is DosBox? DOSBox is a free and open source emulator which runs software for MS-DOS compatible disk operating systems, primarily video games. It was first released in 2002 when DOS technology was becoming obsolete. Its adoption for running DOS games is widespread, with it being used in commercial re-releases of those games as well. So, let us look at the history of DOSBox. The development of DOSBox began around the launch of Windows 2000, when its creators, Dutch programmers Peter Queenstra and Jord van Dieber, discovered that operating system had dropped much of its support for DOS software. The two knew of solutions at the time, but they could not run the applications in windowed mode or scale the graphics. The project was first uploaded to SourceForge and released for beta testing on July 2022. Let us look at the features of DOSBox. DOSBox is a command line program configured either by a set of command line arguments or by editing a plain text configuration file. For ease of use, several graphic frontends have been developed by the user community. Since January 2011, the developers of Wine compatibility layer have integrated DOSBox into Wine to facilitate running DOS programs that are not supported natively by the Wine virtual DOS machine. Since January 2015, the Internet Archive has added thousands of DOS games to its software library. As of October 2019, the DOS library contains 6,934 games. Over to my teammate Likit. Thank you.
Hi, I am Likit. I'll explain you the initial steps in the DOSBox application and how to execute it. In order to do this, you need to mount the file first, right? So, these command prompts will be given to you in the description. It is 8086 is the microprocessor name. So you can see the drive C is mounted. Now you need to change the directory. So prompt is the directory is changed. So I'll be using the word edit. So edit is basically a utility in order to create ASM files and edit those ASM files. Okay. So the syntax is edit file name .asm. .asm is extension used. So you edit. Array is a file name. So now you need to write the code snippet. The code snippet is already been written, as you can see. Now click on file over here and exit. Now any of the code snippet is already written. We need to execute it. So we need to assemble and link it, right? So it's the code is masm return asm. Press enter a couple of times, enter, in order to skip the prompts. So you get 0 warning errors and 0 severe errors. If there are any numbers, you need to write a proper code snippet, bring some changes. Now we will link it. Array.obj. Press enter a couple times so in order to skip the prompts. Yeah, there's no stack segment. The next prompt is capstd file name .exe is the executable file format extension. Yeah, this is the executable file. Thank you.
Hello everyone, I am Joshua. I am here to explain a simple assembly level code on transferring elements from one array to another. So let's go to the code. So this is the code, and this code consists of two segments, X segment and Y segment. Here the X segment is considered as the data segment and the Y segment is considered as the code segment. So in the data segment, that is the X segment, we initialize the values of the two arrays, that is array1 and array2, using the command dw, that is the defined word. So here we are transferring the elements of array1 to array2. So we initialize array1 with 4 values, that is 4 hexadecimal values, and we initialize array2 as 0. Later, we take another variable count, which is the number of values to be transferred, and we initialize it using the command dw, that is defined word. This is the end of the X segment. Coming to the Y segment, initially we assume the Y segment as the code segment and the X segment as the data segment. And now we begin the program by using the command begin. At the beginning, we transfer the elements of segment X into the register. So now we set the register AX as the data segment, and next we transfer the values of array1 as a source index and array2 as the data index using the command of offset. So next we use immediate data transfer and store the value of 4 in the count register, that is CX. And in the next step we are using a loop. Look at the loop here. The first line of the loop is labeled as back, and the first command is in the first command we transfer the elements of source index, that is the elements of array1 into the register AX, and then we transfer the elements of AX into the data destination index, that is array2. Here the first element is transferred from array1 to array2. Now since it is a word, we increment the SI and DI twice. So the next line we increment SI as well as DI, and as one element is incremented, we decrement the value of the count, that is the register CX, and then we use the command JNX, that is JNC, that is jump no 0, to jump back to the label back. Now the jump no 0 is the command that we use to repeat the loop or check the condition. Here, if the value of the count register is 0, then the loop ends and the program will be continued. If the value is not 0, then the loop is repeated. After the loop, we come to the next line where we set the value of AH as 4CH, and we execute the command int 21H. These two are the commands of the DOS interrupt, and which end the program. Following this step, the Y segment ends, and so does the end of the main program. Thank you.
Hello guys, I'm Chetan and I'm going to show you about the execution of the code.
So this is the program counter values. These are the instructions, and these are the Xcode for these instructions. These are the flags, and if we go, and the first instruction is move AX, 48AD. As you can see, at AX the value is 0000. Now if we execute this instruction and move to the next instruction, that is by step over, that is function F8, the AX value will be updated to 48AD. Similarly, we can update this DS value. If you press just function F8, it moves to the next instruction, and here DS value is updated. Then similarly, SI value is also updated, DI value is also updated. All this, then incrementation of SI is done here. It's updated twice. So SI is 0001. Now if we press again, it becomes 0002. Similarly, DI is also incremented. Then next is the jump instruction, where it puts the instruction in loop. Here in this program we put it at the loop for 4 times. Here it's executed once, and as you can see, it returned back to 00E. One time execution is already done. Similarly, now this is the second time, this would be the third time, and this will be the fourth time. And all these, as you can see, all these variables are updated, and the program is terminated. That's all.